Hi and welcome to Getting Started with Grasshopper for Rhino. Before we open Grasshopper and build our first script, let's learn about the foundational concepts Grasshopper is built on. Grasshopper is not just a software, it's a visual programming environment. Compared to conventional programming, visual programming allows us to create programs by manipulating program elements graphically rather than specifying them textually. But in essence, we're building our own programs or algorithms, but without typing any code. By connecting nodes and creating a sequence of components, we're building a program with graphical building blocks. And in those building blocks, Grasshopper combines Rhino's powerful modeling platform with the scalability and control of programming techniques. Grasshopper lives at the intersection between Rhino modeling and programming. It builds on Rhino's core command library and allows us to use programming techniques to control and process large amounts of data at once. Let's take a closer look at which features Grasshopper inherits from both. Almost all commands in Rhino are accessible from within Grasshopper, and for the most part, the components have the same name. We can leverage all the core modeling techniques Rhino has to offer. We can use NURBS curves, extrusions, we can loft, split, run Boolean operations, and much more. Grasshopper also takes advantage of the Rhino display pipeline and gives us a live preview of our script in the Rhino viewport itself. While we don't need to write actual code, we're going to encounter several programming concepts in Grasshopper. Understanding these concepts is essential for working with Grasshopper effectively. One of them is variables. As the name suggests, these are values that we can alter at any time and that are pivotal in defining and controlling the output of our scripts. In Grasshopper, variables take the form of number sliders or input geometry. If we change a variable, the change propagates all the way down the command chain. This allows us to stay flexible and quickly make fundamental adjustments to a complex design. While the value of our variables can change, the functions we run on those variables do not. Grasshopper components are ready-to-use functions that we can run on our variables. Each component will always run the same operations on any input we provide. An offset component, for example, will always offset the input curve. The input curve, which is the variable, can change, but the offset operation, which would be the function, stays the same. We define which variable to process with which component by connecting them visually with a wire connection. And by connecting a sequence of components, we can define a custom set of rules that leads to a specific output. Instead of modeling one instance of a design, we're describing the logic of our design, which means that we can easily adjust any of the variables. The logic of our design depends on the individual design goal and on which key parameters we want our design to be driven by. This means that we will need to design our own component sequences. And by doing so, we're effectively building an algorithm. In order to build our own algorithms, we need to learn to describe a design in terms of the geometric steps needed to generate it. Learning how to break down complex geometries into simple operations is a skill that we'll develop throughout the course. But knowing the sequence of steps is not enough, because components may involve a single geometry or many hundreds of objects at once. This is where data management comes in. In Grasshopper, we can't select geometry the way we do in Rhino. Our selection and object manipulation occurs on a much more abstract level, with lists and data trees. The benefit of this abstraction is that we can access and manipulate data at scale. We can define and select singular items, manage items within a list, and deal with databases containing thousands of items. This allows us to stay in control when processing a lot of geometry at once. We can, for instance, rotate hundreds of facade elements at once, each with their own rotation angle. In Rhino, we would need to rotate each element individually, one by one. Data management is at the core of everything we do in Grasshopper, because every component outputs data. One of our tasks will be to manage and control the flow of the data through the component sequences we create. We'll cover data structures in detail in a dedicated module. But even a robust script will sometimes stop working with a new input or when we change a particular variable. When that happens, the built-in debugging utilities will help us find the problem quickly. Debugging is a term from the programming world, and it describes the process of finding the location in a script where something went wrong and resolving it. There are a few intuitive ways Grasshopper helps us with debugging. One of them is the live preview in the viewport. We don't need to write the whole script before we see if it works. We get visual feedback every step of the way. We also get visual cues on the health of individual components. When a component is gray, everything is fine. When it's orange, one or more inputs are missing. And when a component turns red, it means something is wrong with our input data and the component failed. In addition, tooltip pop-ups when hovering over the component inputs and outputs give us additional information on what's going on. We'll also learn about special components that allow us to read the output of components to understand if the data is being processed correctly. As an experienced Rhino user, you already know a large portion of the commands we can use in Grasshopper to build our scripts. Learning Grasshopper is all about learning these new concepts on the right. If you have experience in a programming language, many of them will be familiar to you already. If not, don't worry, I'll guide you through them step by step. That's it for today. Tomorrow we'll cover the Grasshopper interface and learn how to use it effectively. I'll see you there.